All right, we're recording and we are at 73 attendees, which is fantastic here. Thanks everyone for joining. I think we're just about ready to get started, hey?
Have we started the webinar, Kat?
Yeah, we're
Oh, okay,
recording.
great. Awesome. Well, thanks everyone for joining. Yeah, we're going to get the program started in just a minute or so. If you're logged in, then feel free to scan that QR code in the bottom left and answer some questions while you're waiting. All right. Well, I've got 1 minute past 2 o'clock here in Pacific time, and we're just over 100 participants. So welcome everyone to the next installment of our Geology of series. Welcome to the Geology of Jewelry from ore to adornment. We're excited that so many of you are joining us live right now via Zoom, and then this recording will be made available on YouTube in the future. In case you're joining us later, welcome and welcome to this series. This is a series that started around COVID times as a way to get people together and just kind of keep engaged and networked and excited about all the things that in our lives that geology touches. As you'll see in a couple slides, some of the things we've done in the past. And today we are very excited to present the Geology of Jewelry with 3 amazing speakers. We have the format of this. This is your first time joining. Is a Zoom webinar, so everyone is going to be muted with their cameras off, except for the organizing team and our panelists. But at the end, there will be time. There will be time for Q&A along the way, but then there'll be time for Q&A at the very end, where we can unmute and ask questions live and show our faces. And if you want to show off a piece of jewelry that is really geologically exciting, then we'll have an opportunity to do that at the end. But just in terms of format, if you're wondering, why can't I unmute? That's a little bit of housekeeping on that. Go to the next slide here. And we have a little bit of interactive portion. There's a website here called menti.com, which you can go to and enter that code there in the top, that 8-digit code, or you can just scan the QR code in the bottom right, and it'll bring you to a series of questions that you can run through at your own leisure, and we'll look at them at the end together. There's one slide that says please or pause here. Hold off on that when we go to share the screen. Share some of those. There's a couple of questions that are for after the presentation. So when you see pause here, then just hold off on this last couple. As I said before, this is an ongoing series of webinars, and actually now we've started doing some live in-person versions of this. As you can see here, I don't even think this is all of the ones that we've done in the past, but a pretty broad variety from some what's the word, participatory things like drinking some wine and beer and tasting those, to some other interactive things like painting together with pigments one, and then some kind of fun sports, rock climbing, surfing, and now we're into the world of jewelry. As you can see, there's a website there, and we have one of our organizing committee members, Carla Tucker, is going to be dropping a lot of useful links in the chat. All of the recordings for these events are available on the AAPG Women's Network YouTube channel. And I don't know, actually, I'm going to go back to our title slide because I seem to have forgotten the slide. My apologies. This series is co-sponsored by 3 organizing teams: the AAPG Women's Network, the AWG, Lonestar chapter, and Midwest GeoSciences group. So thank you to our sponsoring organizations. We all work together to put these awesome events together, and we hope you enjoy this one. So I'm going to hand it over to Andrea, introduce our speakers.
Thank you, Stefano, and welcome everyone. I'm so delighted to introduce you to our acclaimed speakers and expert panelists today. First up, we have Carmen Fraticelli. She is the president and owner of Artisan Jewelry Creations. Carmen is a geologist, gemologist, and jeweler with degrees from UT Arlington, LSU, Rice University, and a graduate gemologist diploma from GIA, the Gemological Institute of America. For over 2 decades, she also worked as a regional and exploration geologist and has found a new passion in gemstones and jewelry. After retiring from the oil and gas industry, Carmen began this new adventure fueled by this new passion, and her jewelry is designed to spark memories, invite conversation, and inspire curiosity. She especially loves working with gemstones that carry fascinating histories and geologic backgrounds. You can learn also more about her in her newsletter and blog called Treasure Trove. Our second panelist today is Lindsay Johnson, a Houston-based jewelry artist and metalsmith who draws on her background in geology and creates jewelry under the brand Geophilia Studio. Her work is described as contemporary art jewelry with a focus on 3D elements inspired by Cubism and Surrealist sculptures. As a hand builder, Lindsay works primarily in sterling silver and builds her pieces around her favorite stones. Lately, her work has pivoted to being cast in different metals using the lost wax casting technique. You can also read more and see more of her work at geophiliastudio.com. Our third panelist today is Dr. Rochelle Turnier, manager of the Museum and In-Kind Gifts at GIA. Dr. Rochelle Turner is the manager of the museum and In-Kind Gifts. She works as a steward of the 35,000 specimens in the collection, used for education, research, and displays. Dr. Turnier specializes in sapphire formation, focusing on Montana, Burmese, and alkali basalt hosted sapphires. She an MS from Wisconsin Madison, California since 2017, first intern and postdoc. I'd like to welcome all of our panelists today. Thank you.
Thank you for the introductions. We're going to move on to some slides. One thing that I forgot to mention, a little bit of housekeeping, is if you have any questions, feel free to put them in the Q&A portion, questions that are related to that you'd like to ask to the speakers. And then any other conversations or chat, feel free to use the chat. We've got people monitoring that, and it comes up, we'll take a look in there. So thank you.
Hey, Stefano, just before we kick off, I've got a couple of comments here in the chat about your mic. I can hear you clearly, but you do sound a bit echoey compared to normal. So just to make sure everybody can hear you properly, maybe we'll just make sure that your mic switches to whatever you're using as your primary mic normally. So
how is this? Is this better?
Sounds fine to me, but yeah, let's just make sure if folks have any challenges with that, we'll address them.
Great. Thank you for bringing that up. Sorry about that.
Yeah, no worries.
Well, the last comment I just made was, yeah, if there's any questions, feel free to use the Q&A portion of the Zoom box there at the bottom. We got a little strip of chat, which you can use for general chatting, but any questions you want asked to our panelists, and put it in Q&A, and we'll have a Q&A section at the end of each of our speakers, and then a Q&A in general for anything else that's come up or we might have missed. So, all right, I'm going to advance this next slide, Rochelle, and take it away.
All righty, wonderful. Hello, everyone, and I'm very happy to be here today. Obviously, we're all here because we love jewelry, but one of the things that most people don't have a concept for is the pathway of a gemstone all the way through the hands it interchanges all the way to your jewelry. So I'll split this up into kind of 2 separate channels because colored gemstone mining and diamond mining are very different. On the left here, we can see a Thai ruby miner. Most colored gemstone deposits are secondary and they're mined artisanally. So this means small local communities get together and People can find mines in all kinds of ways, but once a deposit is identified, local people will start mining there. And this is often by pretty low-tech kind of tools. This gentleman is using a gem sieve or a saruka, and he's basically picking up the stream gravels and looking for rubies in there. You can compare this, or contrast it rather, to diamond mining. On the right here, we have a Russian diamond mine. And one thing you see in this image on the right is there are three kind of square things. Those are actually dump trucks with wheels that are taller than I am tall. So these are really, really huge trucks, and you can see the scale of the mine in comparison to those trucks is just gigantic. And so what they're doing at the diamond mine is they're mining the hard rock. They're basically blasting off the diamond-bearing kimberlite, trucking that all the way out up those roads that go around and around, and then processing it. Next slide, please. So you can see that the sort of sorting and processing for these two different types of gemstones are also very different. On the left here, we have a ruby mine in Burma. And this is a female worker. She's actually called a kanase because they're allowed to mine the material, the tailings of the mines there. And so she's picking through the gravels and using her gem sieve or saruka. And if you're good and you shake it back and forth and kind of loft the gems, the denser material will go to the center. And then when you flip it over, if you've done a good job, your gemstones will be in the middle. And you can kind of get a sense of that in the upper photo on the left, where you see the center of that pile is kind of darker and more black. And then on the bottom, you can see the rubies and spinels that she's picked through and is going to put them in that little jar and bring it home at the end of the day. Diamond mining is very different. This is a very large scale process. So here you see a conveyor belt that's bringing, excuse me, kimberlite that was mined up through the sorting plant. Diamond mining technology has really gotten way more advanced in recent years. And so nowadays, they even have something called an X-ray sorter. And what this does is basically detects the X-ray signature of a diamond. And you can see the schematic for the X-ray sorter on the top of the conveyor belt image. And then what it does is when it gets the right signature, it has the timing down and everything, and it'll send a brief puff of air that basically shoots that diamond into a different receptacle compared to the waste rock. And one of the interesting things is that many people, most people who mine diamonds actually have never actually seen a diamond in matrix because this process is so automated and mechanized, and just the scale of the entire operation is very large. Next slide. So what do the markets look like for these two types of gemstones? Markets can be either small or large. On the left here, there's me at a Burmese gem market. So all the miners and the traders have come into this area, and almost like a farmer's market, they've brought their wares. And so this is everything from rough gemstones to faceted gemstones. And all the traders are kind of crowding around me because I said, well, I'm looking for star sapphires, and word spreads quickly. And so everybody with star sapphires comes flooding you and, oh, look at this, look at this. And on the right, you have a diamond bourse. So diamond trading is very different. Usually what happens is that there are several large companies that basically have what's called a site. These site holders have a contract with a diamond mining company to buy huge bundles of rough. And then those are traded at the diamond bourse, which you can see a photo of the diamond bourse building. This is in Germany here. And this is almost like a stock market floor where there's all kinds of trading. You know, here's what I want for this slot of diamonds, looking through parcels of diamonds, and so on and so forth. Next slide. Gemstone faceting is also different for these two types of gem materials. So on the left here, this is actually a gemstone faceter, and he's actually at the house of the mine owner. This is Bamar Mine in Burma. And in Myanmar, or Burma, there's a lot of industrious people, and they're not always using the same technology that we have here. For example, this gentleman is actually operating the lap, so spinning it with a foot pedal, actually. And then the gentleman on the right is actually putting the facets on the gem at the gem miner's house. And so sometimes gems are faceted at the source or close to the source, but other times they're faceted away from the source. So this might be somebody on the international market who either goes to local gem markets and picks up materials or buys it from somebody who has done that, and then they would facet it themselves. Next slide, please. Diamond faceting, excuse me, is very, very different. So you have a lot of value in diamonds, but also diamonds have, all materials have inclusions. And one of the things that you can do is actually use computer technology to say, okay, here's my diamond rough. Here are where my inclusions are in that diamond rough. And so you can actually plan out, how do I maximize the number of stones that can be cut from this one piece of rough? And then on the right here, you can see that the gentleman is actually using a computer to assist with the diamond bruting process, which is basically where you turn it into a round shape. And oftentimes, this man is actually doing it by hand, but nowadays they cut diamonds with lasers quite often because it's accurate and you have greater weight retention at the end. Next slide. So what happens after that is usually materials are sent to a gemological laboratory, like the Gemological Institute of America. One of the things you want to know if you're buying stones is this stone actually what somebody told me it was? Because even if you're at a local market, people love to throw in all kinds of different things. You know, there are very scrupulous traders and gem dealers, and then there's always, you know, a bad opportunistic actor here and there. So when you're looking through parcels of rough, you might have experienced eyes, but you would also want to check later and see, is this glass or is this actually a sapphire? And if this is a sapphire, has it been treated in any way? A lot of gems are treated, and gem treatments aren't bad. It's just disclosure that is important, because you want to know how the gem is treated. Is this stable? Is this, you know, has it been filled? Is the filler going to yellow over time? You want to know what you're dealing with. So there's a whole host of tools that gemologists would use in a gem material to try to derive these answers. And so some of those are the specific gravity or the refractive index, you know, the weight of it compared to water, or how it bends light. What do the inclusions inside of it look like? Are they kind of crucible inclusions like platinum or things that would tell you that this is a synthetic gem? Or do they look like they've been exploded? Maybe this is a heat-treated gem. There's also a whole host of spectroscopic tools that we use. This is also confirming the identity of the gem. Different things like, has identifying the oil or filler, or has this been treated in any way? And those spectroscopic tools will help you with that. You can also use photoluminescence mapping to tell the distribution of different defects or trace elements within a material. Acetone will tell you if something has been dyed, because if you touch a little Q-tip of acetone and it has been dyed, you will get some dye on your Q-tip. And then our real workhorse is the laser ablation inductively coupled plasma mass spectrometer. And this will tell you chemistry. This will tell you anything from, has this stone undergone beryllium diffusion to change its color? And it's also importantly used in our geographic origin services. There's a lot of interest in knowing where in the world that gemstone was mined from after it's actually been pulled out of the ground. And this is partially because of rarity. A really nice Burmese ruby has a lot of value. And so people want to know, is this actually a Burmese ruby? Next slide. So now I'll talk to you briefly about the front part of that process is where do you find gemstones? How do gemstones occur? And I'll talk specifically about one of my favorite places, which is Myanmar or Burma. Myanmar is a very special gem locality. Here, this list of words and different gems on the screen, there's actually over 55 of these here. And in fact, some of them are very rare. All these minerals on the screen occur in gem varieties in Burma. And some of them very rare. There's only 1 or 2 varieties in the world, specimens in the world rather, that have been found. And that includes John Koivulite, which is named after GIA's expert photomicrographer, John Koivula, Chatuite, which is named after one of the Burmese guides who's taken many, many people to Mogok, and then also the valley where you find a lot of these gemstones. And then Painite, which is named after a British gemologist, Arthur C. Payne, who spent a lot of time in Burma and actually lived there for a long period of time. Next slide. So why are there all these gems here? Well, one of the things is India wasn't always in its current position, and you can see on this image in the left that over time, the Indian plate gradually migrated and slammed into the Eurasian plate. This is what gave us the Himalaya mountains. And in that process, it scraped up all the seafloor sediments. I'm sure you've heard stories that on the highest peaks of the Himalayas, they find, limestone materials with shells in them. That's because they used to be in the ocean. And so during this process of the landmass smashing in and crunching up everything there, you got a lot of folding, you got fluids, you got intrusions, you got metamorphism. And those are kinds of all the settings that you would need to form different gemstones. And so there is just this incredible variety of gemstones out there. Next slide, please. But I really have a lot of respect for people who can find gem deposits. It's not always easy. On the left here, this is a Burmese deposit, Lonestar. Not only is this deposit about 2 hours up a dirt road that's half washed out in the mountains, but it's also incredibly vegetated over there. So I really have to wonder how somebody found this deposit. I mean, even if you're told, okay, I see here the limestone and this is intruded by a syenite right here, you're like, yeah, sure, I guess so. Like there's so many plants there. It's really not easy like doing geology in the desert where nothing's obstructing your view of what you're trying to look for. And also a lot of these deposits are limited or difficult to access. For example, the Mogok Valley in Burma, you have to obtain special permission as a foreigner. Here we are waiting at the guard gate with the GIA field gemology team, and the Burmese guys are giving them our paperwork and saying, yes, these are the guys and they've been approved to enter, because otherwise we would have not even been able to enter this valley. This is the whole valley that's closed off to foreigners. So there's a lot of value in people who can go to the source, trade in the local markets, and then also get those gemstones back to somebody who can facet them. And then someday, somebody, as our later panelists will talk about, will fabricate it into a beautiful piece of jewelry that you will love and wear. And so when I think about all those different steps and all these hands that have interchanged this gemstone, not to mention millions, perhaps billions of years that it was sitting underground in the earth forming, it's really, really special that we have the opportunity to wear something on ourselves that has this incredibly long and just fascinating history. So thank you very much, and I'll take any questions that you have, or you can save them for later.
Yeah, do we have any questions in the Q&A chat for Rochelle?
No, I don't see
Okay.
any questions yet. I did just enable the chat as well. But folks, if you've got questions for the speakers, definitely throw them in the Q&A. That's the easiest way for us to parse them out. But
And we'll
yeah,
have another part for Q&A at the end. So if you thought of something for Rochelle, then we can ask it at the end too. All right, moving on. Carmen, I'm going to give you control of the slides. All right. Right.
Got it. Thank you, Stefano. So, diamond is the birthstone for April. So, it's great that I get the chance to tell you about Argyle, which is many people considered one of the most important diamond mines in the world. A lot of people know that Australia has a lot of natural resources, but diamonds tend to come as a surprise to a lot of people. Diamonds were first discovered in Australia in 1895, which is only 30 years after they were discovered in South Africa, and about 15 years after Cecil Rhodes consolidated all those mines and created De Beers. But the location of these is pretty far out there. It was in a stream bed, and people started looking all over the place for more diamonds. But over 80 years, when they were searching, they couldn't actually find the original source. No volcanic pipes were ever found. In 1969, however, some diamonds were discovered in an alluvial deposit in the Kimberley region of Western Australia. At this point, a number of mining companies decided now is the time to really get serious about this. So they created a JV and they started systematically exploring 190,000 kilometers using geologists as team leads. This ended in 1976 with the discovery of the diamond-bearing volcanic pipe. They were very excited about this and continued as well. But the discovery of the pipe meant that there were pipes in Australia. And so then the race was on to find more. What we're going to go through today in the next few slides is not the story of that pipe. It's one that follows, one that's called Argyle. Argyle did more than just provide diamonds. It actually changed the world through geology, business, economies, government, regulations, and obviously accessories. But the likelihood is you've probably never even heard of it. So we're going to start the story with Maureen Mugridge. She was a young geologist with a degree from St. Andrews University. She looked for work in the UK, where she was, but she couldn't find any. So she emigrated to Australia, arriving in Perth in 1972. Her family had paid for the passage, but she only had about 10 pounds in her pocket when she arrived. She started looking for work, and in a few weeks, she was offered a job looking for diamonds. She thought it was a joke, but a job's a job, so she accepted it. The company that gave her that job was one of the ones of the JV that was searching Western Australia. Well, it turns out she loved doing this. She really took to it. She was exploring alluvial deposits, looking for those elusive diamonds, and very soon she started leading her own teams. One of the teams she was leading decided to focus on an area near Lake Argyle. Even though she was 6 months pregnant, she took a team on a sampling run to Smoke Creek, and they discovered diamonds. It was interesting because De Beers had previously spent months looking in that area and found nothing. So legend has it that to keep the rival teams off their back, they sent out word that Maureen was going on maternity leave and her team was standing down. But it wasn't true. In October of 1979, they discovered the volcanic source of those diamonds, AK1. Whoops. AK1 turned into Argyle, the largest diamond mined by volume in the world. If you look at the graph on the side there, which shows you the annual world production of rough diamonds, that pink area is essentially all Argyle. So when I was an undergraduate, and some of you is probably true as well, we learned about Clifford's rule, which tells you that diamonds are only found in kimberlites that are on Archean cratons with deep mantle roots. But Australian diamonds don't follow that rule. The volcanic pipes were not kimberlites, they were lamporites, which is a similar but different volcanic explosion. They also weren't on the craton. They were in the Proterozoic mobile belt adjacent to the craton. This new geologic paradigm took a while to get across the world, but it did, in fact, give us an important add in our understanding of diamonds. The geologic history of Argyll itself is also very interesting. It starts with the subduction and the associated orogenic belt that became there because of the assembly of the supercontinent Nuna. That happened about 1.8 billion years ago. That set up the conditions for the diamond formation, which is about 1.58 billion years ago. When Nuna started breaking up, which started about 1.3 billion years ago, that's when the lamporite pipes, dikes, and explosions happened. That might have been started due to a mantle plume, but we don't know. In the early Cretaceous, some of those volcanics were eroded and then transported across the landscape in fluvial systems. Now, this is a very interesting geologic story, but you don't just see it in the ground and in the rocks. You can actually see it in the diamonds themselves. So Argyll produces white diamonds, but it also produces a lot of brown and also some pink, red, and violet diamonds. Browns, pinks, and reds are colored that way not because of trace elements, which is what happens to most colored diamonds or even colors in other gemstones. This is caused by plastic deformation of the crystal structure in a high-strain environment. What happens is the plastic deformation causes graining in the crystal, which you can see right here. That graining actually absorbs some of the parts of the visible spectrum. And so we end up seeing pinks, browns, and reds. Now, Argyll produced these colors, especially the pinks, reds, and violets, not in a lot of percentage, but it was consistent. Right? So what that ended up being for the world is that 90% of the world's pink diamonds came from Argyll, and all of the world's red and violet diamonds only come from Argyll. Argyll also had a whole lot of other firsts. It was the first diamond mine to use only outside industry financing, which becomes important later. The JV argued for fly-in, fly-out setups in mines, which resulted in changes to the government regulations. They signed what was called the Good Neighbor Agreement in 1980. This was one of the first agreements between mining communities and between mining communities and indigenous communities. The JV also really encouraged the recruitment of women and indigenous workers, which was not at all common in 1980. Now we're talking diamonds, so we absolutely have to talk about De Beers. But unfortunately, the very long, fascinating, but complex history of De Beers is way too much to cover here. But what I do need you to understand is that at the time of Argyll's discovery, De Beers was immensely important. It was a monopoly and had a really tight and strong alliance between the miners and the merchants. What was originally named the Diamond Syndicate later became known as the Central Selling Organization. So to sell their diamonds, Argyll had to enter into a partnership with the CSO. But the partnership was strained from the very beginning. There was a lot of reasons for that. The first being that De Beers had no equity in Argyll. and that was because they had been kept out. Also, because the Australians weren't part of the traditional diamond industry, and sometimes they behaved as ways that the traditional diamond industry didn't expect. It was also important that the CSO thought that the brown diamonds weren't very interesting, and they considered them industrial grade. Now, I'm going to take a small aside here because we are talking about De Beers. In 1938, De Beers hired Ayers and Son to advertise their diamonds. They assigned this to a junior copywriter named Mary Frances Garrity because diamonds were women things. She created "A Diamond is Forever," which is widely considered one of the most successful taglines of all time. So back to Argyle. In 1996, the JV decided that continuing the partnership with the CSO wasn't really worth it. So they decided to go it alone. So De Beers decided to do the things it usually does when groups decide to try to walk away. But the decisions that the JV had made prior to this point actually resulted in those actions not having the intended consequence. So, as we said earlier, De Beers didn't have any equity in Argyle, and they intentionally never took a loan from the CSO, which means there were no financial levers for them to move. So what they did was they tried to flood the market with small diamonds. But the JV had started quietly building a relationship with Indian facetors. The Indians were not the preferred cutters for De Beers. And so when De Beers flooded the market with small diamonds, the Indians reacted by buying up all the excess, which meant the price never crashed. The other thing is the JV decided that the viewpoint that the brown stones were worthless wasn't correct. They decided to market their stones as fancy colored diamonds, and they used the terms champagne and cognac. These were terms that were already known to high-end jewelers, just not the general public. So Argyle's defection is very important here. They were the first group to be able to actually break away from De Beers. By the time, at this point, when we get to this point, De Beers' history, De Beers had controlled the vast majority of diamond in the world. But at this point, when the break happened, that started to unravel. In the year 2000, when De Beers finally announced it was abandoning its monopoly of the world supply, that percentage had dropped to 63. Today, it's 26. Sorry about that. So let's go back to talk about the Indians. So in the diamond industry of the 80s and 90s, both the Australian miners and the Indian cutters were essentially outsiders. They were not part of the in crowd. But the Indians had started buying Argyle diamonds in Antwerp, and the JV took notice of this. And they started building a relationship and a partnership with the Indian cutters. De Beers preferred sending their diamonds to Antwerp, Tel Aviv, and New York. But the Argyle diamonds tend to be on the smaller side. So the combination of skill and lower labor costs that India could provide made more sense. So together in their partnership, they started to create new technology and techniques to process Argyle type diamonds in quantity and at lower price points. This meant that more diamonds were available to everyone. It also meant for India more jobs and a major expansion of their jewelry industry, which exists to today. So being able to cut many more diamonds and having them at affordable price point led essentially to what was termed the democratization of diamonds. So jewelers were able to take many more of these diamonds and start using them in cluster rings, halos, and pave set pieces. Jewelry stores that are in the mall were able to expand their jewelry inventory. What you see today is that the majority of inventory in those stores has diamonds in them. Suddenly, everybody could wear diamonds. It wasn't just for the wealthy. Today, there's almost 1 million diamond cutters in India. And the amount of people working in their jewelry industry is even bigger than that, right? It is often said that 14 out of every 15 diamonds set in jewelry have likely been through a Surat workshop. Now, colored diamonds traditionally have only been reserved for the ultra wealthy because they're very rare, right? But Argyle was able to put out many more colored stones. Prior to Argyle, most people hadn't seen a colored diamond, and many of them didn't even know of its existence. So the campaign with the champagne and the cognac brought attention to colored diamonds, and the really beautiful, very rare pink, red, and violet ones also brought more attention. In 2000, the new CEO of Levion, which is a 500-year-old family business, visited Argyle. He found that the brown stones were special, and he found that these were an opportunity for the middle class to own fancy colored diamonds, which normally they wouldn't be able to do. So Levion created chocolate diamonds, which is their trademark. These were out of a high-quality subset of Argyle cognacs. Argyle was the sole supplier of chocolate diamonds, even as Levion became a global luxury brand. Now, jewelers, because of the Argyle diamond, started using contrasting color stones and more colored stones in their designs. And that trend expanded outside of the colors that Argyle was able to provide. So black and white contrasting diamond designs became very popular. And that extended into other colors of diamonds as well. And you can see a lot of those today as well. So after 37 years of production, 865 million carats of rough diamond, and an outsized influence that stretched across the globe, Argyle closed on the 3rd of November in 2020. Today, the area is undergoing reclamation, returning it to what it used to look like, but they're doing so with the input of traditional landowners and the government. So I'm going to thank you for listening. If you are interested in stories like this about gems, jewelry, and history, I'll invite you to visit my blog, Treasure Trove. You can also see examples of my work there. I use very colorful stones, a lot of times stones that are only found in one place in the world. I use different alloys of silver and gold, and they're all hand fabricated. And in a few minutes, our next panelist, Lindsay, is going to tell you what all that means. Thank you.
Awesome, Carmen. Thank you so much. Do we have any questions for Carmen for her section?
We do not. We have lots of claps and hands up,
All
or
right.
good reactions, but no questions. So if anybody has questions, throw them in the Q&A.
Yeah, and like I said, we'll have a Q&A. Oh, I see one popped up. Yeah, is that someone to ask now?
Somebody is asking what happened to Maureen.
Oh,
Any
yeah, good
feedback
question.
on that?
Oops. Maureen, I forget her last name, Muggeridge? Carmen, do you know?
So Maureen continued with the JV for a while. Eventually, she actually started her own diamond mining company. She actually died of a stroke while exploring for diamonds in Australia.
Wow.
It's awesome. I mean, not, it's an awesome story. Sorry, that's one. Yeah.
Yes. Okay, another question from Gigi. What about yellow diamonds? Where do they come from? Do you want to comment on that, Carmen?
Sure. Yellow diamonds come from a lot of different places. Actually, in the story I just gave you, that first pipe that was discovered actually produces some really beautiful yellow diamonds.
Mm-hmm.
Yellow diamonds are yellow because of impurities, nitrogen. They're not caused by the same mechanism as the ones from Argyle.
Mm-hmm. And do we have time for any more questions? Steph? Okay. So Veronica asks, why did Argyle close exactly? Was it sort of end of life or resource
Yep,
depletion? What do you think?
yep. Essentially, they had mined it all out. It's not so diamond mines at a scale are big, but it's a limited area that actually has the diamonds in it. So they only last a certain amount of time. And Argyle lasted for 37 years.
Okay, so thank you, Carmen. Jeffrey asks, how many other source pipes were found in that area?
Um, Argyle was only the one. It's a little bit of a complex rather than just one pipe, um, but in a really, really tight area. There are other pipes in the Argyle area, but they weren't diamondiferous. In the first pipe is called Ellendale, and they are a little bit more spread out. And several of those, I think two in particular, had diamonds in them. There's another diamond area that started to be developed sometime after Argyle, which is called Merlin. And I believe that's east of Argyle.
Hmm. Okay. The last question I see here is what is the effect, it's from Scott, what is the effect of lab-created diamonds on Argyle and De Beers? That's a great question. Synthetic diamonds
Well,
versus the real thing, I guess.
right. So at this point, it has no effect on Argyle because Argyle is
Yeah.
closed. Um, and so lab created diamonds have had an effect on the natural diamond industry. There's a lot of debate out there. Some of natural diamonds have actually decreased in price. Lab created diamonds have dramatically decreased in price.
Hmm.
Um, and there, this is a hotbed of debate out there, so I'm trying hard to figure out how to answer that question. But they have had an impact. There are some people who absolutely will not use lab created diamonds. There are some people who absolutely won't take natural diamonds.
Mhm.
And I think as time goes on, we'll have to wait and see how it all works out. Um, like I said, there are price impacts. De Beers actually did start its own lab created diamond group for a while, but I think they shut that one down.
Mhm.
De Beers is essentially at this point, it is a subsidiary of Anglo American, and there's a lot of question as to Anglo doesn't want it anymore. They're trying to sell it, and nobody really knows who's going to buy it. Um,
Mhm.
but lab create, they're done. Um, they're done in lots of parts of the world. China and Russia are very strong places to create lab created. There's a few here in the United States as well.
Mhm. And thank you for that. I think I'll just sneak one in from our organizing team here. Andrea asks, with Argyle closed, where does Levian, if I'm pronouncing that right, now source
Levian.
their Levian source their chocolate diamonds from today?
That's a really good question. So I know they have a stockpile of chocolate diamonds. Um, they have yet to change their website. They have yet on their website to acknowledge that Argyle has closed.
Mhm.
De Beers started a new marketing campaign recently called Desert Diamonds. And these are kind of light yellows and light browns and kind of the same sort of thing. They're not as dark or as deep as Argyle diamonds were. And so some of the new stuff coming out from Levion is part of that desert diamonds stuff.
Mm.
But I don't know what they're going to do in the future once they run out of the chocolate diamonds that they have.
Fantastic. Well, that's all the questions. We'll move on. And if folks think of anything else, feel free to throw it in the Q&A and we'll also address it at the end in our official Q&A section.
Cool. Thank you very much. Thank you, Carmen. Move on to Lindsay. I'm going to advance the slide and then give you control.
All right. Okay, hi. So I'm going to talk a little bit about the geology of alloys and the history behind them and what we do with them now. So if I can get this going. I don't think I have, it's not letting me.
You got control, but I'll click for you.
Huh, interesting.
Here we go.
Okay, so all metal jewelry begins as ore or mineral deposits. So copper, gold, and silver all come from specific geologic environments. And these metals can all be alloyed together in different ways to create the settings that we hold our precious stones in so that we can wear them and take them around with us. I like to think that mining and metallurgy connect geology to art because once humans learned how to extract metals from ore, combining them together changed everything. Suddenly, weapons were sharper and stronger, large sculptures and art could be made, and jewelry became more durable and a little more affordable. Next slide. So alloys are a combination of two or more different metals and sometimes non-metals to create a brand new material. We don't really know how or why people discovered alloys. I like to think they were looking for new versions of things they already had, like weapons and tools. And they already knew the properties of the native metals they were using, like how copper is soft and easily to work, and how tin is maybe a little bit harder to work. And they thought, well, what if we just melt these together and see what happens? And then civilizations were born. Next slide. So before metals can be alloyed, they need to be removed from their ore. And that's done through a process called smelting, which uses very high temperatures and reducing agents like coke or carbon. And the carbon essentially grabs on to anything that isn't the metal and washes it away as slag. And from there, the molten metal can be poured into ingots or bars and then rolled into sheet or pulled into wire and used to make tools, weapons, and jewelry. Next slide. So many of the metals we use in jewelry are alloys rather than pure elements, because as pure elements, metals are just too malleable, too easy to work, and too soft to hold any kind of enduring form. So, so this is copper in its native form before it's removed from its rock. And in the bottom right picture are some objects that I made using copper sheet, where I cut out different shapes and folded and hammered and annealed and then unfolded to create leaf and flower structures and little swirlies and even a bracelet. So you probably heard me say anneal. As you work metal, it gets harder and harder until it cracks or breaks. So we use heat to soften it and relax the metal. I use a flame. Sometimes people use a kiln, but you just heat it till it's red hot, and that relaxes the metal so you can continue to work it. Next slide. So from copper, the first alloy that we have is bronze. And bronze is a combination of copper and tin. So the addition of tin to copper makes it harder and more durable, and it keeps an edge better, which is great for tools and weapons because it can keep a nice sharp edge. Like in the middle picture, we see some ancient bronze axe heads and spearheads. So not only can we make weapons and tools from it, but now that it's harder and holds a form, we can make art and sculptures and ornaments. So the picture to the right shows a lot of our several rings and bracelets, some clothing pins and earrings. And the bottom left picture is a ring that I actually carved from wax and had cast into bronze. Next slide. So the next alloy we have from copper is brass. And brass is a combination of copper and zinc. And it took a lot longer to discover brass because zinc is notoriously tricky to isolate because it vaporizes at high temperatures, like the temperature you need to melt copper. So if you tried to melt zinc and copper together, the zinc would just evaporate. So what they used to do was melt smithsonite ore with copper, and somehow the zinc vapors would permeate the copper and make a material called calamine brass. But the brass that we know today was actually discovered in the 1700s. And it's a little different from bronze because the zinc makes it have a nice warm gold color, which is really similar to solid gold. So then vessels and jewelry could be made using brass, but it looked just like gold, but it was a lot less expensive. So you can see some vessels in the top right, and the bottom right are some pieces that I made from brass sheet. So when you fold metal and crease it, it tends to hold that shape kind of no matter what you do. So as jewelers, we can fold it and crease it in different ways and then unfold it and kind of flatten it a little to get some really great textures that we can use. And since brass is so much easier to work than bronze, we actually make musical instruments out of it, like saxophones and trumpets. And here are some baritones and a tuba. So while copper alloys created strong and beautiful materials, jewelers eventually began working with another metal that had very different properties. Next slide. Silver. So this is how silver looks in its native form before it's removed from its rock. Next slide. So silver comes in a few different varieties. The first one is fine silver, and it's 99.9% elemental silver, the purest you can get. This is really nice because it's soft and easy to work, which is great for bezel settings around stones and also wire wrapping. And it has a nice bright white color because it doesn't tarnish very easily. So it's great that it's soft, but also it's not great for some things like rings and bracelets because it tends to deform easily. But if your silver sheet is thick enough, you can make vessels out of it, like the vase on the right side. Next slide. So the next alloy of silver is sterling silver, and it's 92.5% silver and 7.5% copper. So the addition of copper to silver makes it harder and more durable for jewelry that you're going to wear on your hands. But the drawback of adding copper is that it tarnishes more easily than fine silver. This isn't really a problem as long as you keep your sterling silver in a box or an airtight container. Or if it's jewelry, just wear it. because your skin rubs off the oxidation process or the oxidation product that we know of as tarnish. Okay, next slide. The third kind of silver is argentium silver, and it's kind of newer. It was discovered in the 90s, and it's 94% silver, 5% copper, and 1% germanium. So that extra little bit of silver in there makes it much more tarnish resistant than sterling and gives it a bright white color. So you can see in the picture here that it's a lot brighter than the sterling silver next to it. Next slide. So once we have all these metals, how do we go about making jewelry from them? So I'm going to talk a little about the low-tech techniques like working with wire, all the way through to casting, which is a very involved process and uses a lot of different tools and techniques. Next slide. So wire wrapping is probably one of the first ways that they made jewelry using stones, because all you really need is wire and stones, wire cutters, and a couple of different types of pliers. And wire wrap jewelry can be as simple as the pendants in the middle picture, or as detailed as the Nautilus pendant in the top right picture. Next slide. So next is hand fabrication. And this is actually how I make most of my jewelry. So it involves sawing and hammering and soldering, polishing and stone setting. So in the top picture, you can see I traced out some settings for those stones. And what I would do next is saw them out of the sterling silver sheet, make their settings, file and smooth off the edges, and then solder that to components like ring bands or bails for pendants. So the bottom right picture is me at my soldering station putting something together. And on the left picture, I'm just filing the edges of a ring just to round it off and make it smooth so it doesn't cut you when you put it on. Next slide. Next. Okay. The next technique is raising metal. So first we'll talk about scoring. So in the top left picture, I made these earrings by scoring along some lines, which means just kind of cutting out some of the metal a little bit, and then you can fold it and unfold it in different ways to get 3D objects. And we talked a little about fold forming already. It's like in the top right picture or the brooch in the bottom left. It's really just about folding and hammering along different edges to get different and interesting forms to create 3D pieces. So you can also raise vessels, like in the bottom right picture. The artist created a cylinder out of sterling silver sheet. And then all those lines that you see on there are guidelines for where she's going to hit to get the shape that she wants. Because to stretch metal, or metal stretches in different ways depending on how you hit it, where you hit it, and what kind of hammer you're using. So it's a good idea to draw on there where you want to hammer so that you can get the shape that you want. Okay, next slide. So next we'll talk about casting. And to begin casting, you start with a wax. So we can carve hard wax, or we can mold soft wax, or we can use something called the buildup method, where you use a hot tool, pick up some scrap wax, and then just kind of dribble it over like a tracing. So the picture to the right shows some blocks of blue hard wax, and I cut like a little star shape out of it that I still need to refine. And the purple squares underneath the star is something I made using the buildup method. So I really just drew some squares on a piece of paper and then used my soldering iron to pick up some melted hot wax or scrap wax and then dribble it over the squares over and over until it was the thickness that I wanted. And then you can just peel it off the paper and get it cast. I just think that's a really cool technique, and I can't wait to explore it more. So the picture to the left are a couple of pieces that I had cast into bronze. And the green is actually what their waxes would have looked like before they were cast. So that is made from soft sheet wax. It just comes in like sheets, and you can cut different shapes out of it and fold it just like metal and texture it how you want and then have it cast. Okay, next slide. So once you have your wax, you need to put it in a flask for investing. So in the bottom left picture, you can see the artist carved like a coral fan shape. Well, in the blue one, it's got that little tongue sticking off. That's called a sprue, and it acts as a conduit for the molten metal to flow into where the wax is during the casting process. So you have your wax, you put your sprue on it, and then you can you affix that to a flask like in the right picture. And then you pour in a liquid investment, which hardens, and then you put that whole thing in a kiln overnight so that the wax inside can burn off and leave like a hollow space. Next slide. So then you take that flask from the kiln and you put it in your centrifuge right behind the crucible. So you see the person is holding a handle in this picture. You grab that handle and you wind it a couple of times until it's tight, and then you hold on to it. And in the crucible, you put your old jewelry or scrap metal or casting grains, and then you get a big flame torch and melt it until it's melted into like basically a ball. Because when you melt metal, it balls up. So when it's a nice molten ball, you let that handle go and it spins real fast, and the forces suck that molten metal in through a small hole in the crucible, through a hole in the flask, and then into the space left by your wax. And then you have your casting. So you take that flask when all of that's done and spun down, and you dunk it in water to dissolve the investment so you can retrieve your casting. Next slide. So once you have your casting, you have to clean it up. So these are some pieces that I had cast, and you can see on the corners, all those little nubbins, that's where the sprues were. So you have to grind and file and sand that off. And then you can polish and put on components like ear wires or set any stones. Next slide. So say you cast a piece and you really like it, and you want to create a whole jewelry line around it. Well, it's a good idea to make a mold. So you get your masterpiece and you sandwich it between two pieces of rubber. And using heat and pressure, you smash that together until the rubber has molded to itself. And then you can cut it open and you see that it makes an impression of your masterpiece. And from there, you close it back up and you can inject it with liquid hot wax to get more waxes, like in the middle picture. You can do that hundreds or even thousands of times before your mold kind of wears out. So the left side is a mold that I made, and in the middle is the masterpiece that it's made from and a wax that I pulled from the mold. So if you want several, you pull several waxes, and then you have to go back through the process all over again. You sprue it to a tree, like in the right picture here. They pulled a bunch of different waxes and they sprued them to a flask tree, and then you cast that whole thing. So what you get afterwards is what's to the far right. That's a whole bronze or brass casted piece. So then the jeweler will have to go in and clip off each one of those pieces of jewelry, sand it, file, finish it up, and set any stones. And then all of a sudden, you've got like maybe 100 pieces. Okay, next slide. So I just wanted to talk about my company a little bit. It's called Geophilia Studio. Geophilia is Latin for earth loving. which is a little bit of a callback to my scientific background. I have a master's in geomicrobiology and actually worked as a geologist for a number of years before I turned my hobby into a business. So most of my work is made with sterling silver, but I am starting to move into brass and bronze as I navigate the casting world. My pieces are modern art jewelry that focus on 3D forms and sculptural elements because I'm really inspired by Cubist and Surrealist art and sculpture. So the bottom left picture is a handful of my tools on my workbench. And to the right are some pieces that I made last year that are from a collection called the Lucida collection. Lucida is Latin for bright and shining. And I wanted this collection to capture the emotion of seeing 19th century artist renderings of celestial phenomena, like comets flying through space and sunbursts and supernovae. And the lines on the jewelry, the textures, give it that kind of movement that you see in those photos. And I also really wanted it to evoke the emotion that you get when you hear what Carl Sagan once said, in that we're all made of star stuff. We're all connected in this universe. And so that's what I wanted this to embody. You can find me at geophiliastudio.com and on Instagram at geophiliastudio. Okay, next slide. So jewelry is wearable geology. Every piece carries a long story from beginning as ore and mineral deposits, going through the smelting process to become usable materials, all the way to the maker and the craftsperson using those materials to create something beautiful and useful. Okay, that's it. I'll hand it back to the host.
Thank you, Lindsay. Thank you, all of our speakers. And I love that this is kind of the end of the technical session or technical section, but that really is kind of an encapsulation of the theme today. Jewelry is wearable geology. So I love that final slide. Do we have any Q&A for Lindsay specifically? Feel free to drop it in the Q&A. And
Yeah, I see another diamond question. So maybe while folks are thinking about the idea of wearable geology or with jewelry casting and all that good stuff, I'll just ask Diana Lamb here asks about pink diamonds. So maybe going back to Carmen, any feedback on pink diamonds, where they
Um,
come from?
yeah, you can find, well, the miners can find pink diamonds in a number of places. They're just even more rare than before. They also have a slightly different color. Um, Pink diamonds from other mines tend to be a bit paler, a little bit. So the pink diamonds in Argyle had some purple undertones sometimes, a little bit brighter. You can find, so there's one called Golonka pink. There are some in the Russian, but they're pink and they're definitely rare pinks, but they tend to be a little bit paler.
Mm, fantastic.
awesome. Any questions for Lindsay on all of her discussion of process and making things? Oh, something coming up.
Okay, so question from Anya. When you say that metal holds its shape once it has been worked, how do you reverse any changes you might not want to have made, basically? You...
Well, you can't. Most of the time, if you do something intense like creasing it, it's not going to come back. You almost just kind of have to melt it down and re-roll it out. If it's a little scratch or maybe a dent, like a small dent, you might could sand that out. But mostly once it's creased, that's it.
Mhm.
Mhm.
It's not for the faint of heart.
No, especially with these silver prices.
Yeah. And speaking of which, I've never really looked up what the difference is between sterling silver and other types of silver. So that was just learning those little things that you use every day and you don't even think about. So
Yeah.
fantastic. So Gregory asks, do we have any estimations of remaining gemstone resources? So I guess is there any criticality to certain gemstones? Anyone want to comment on that?
Well, I'm going to say it depends on the gemstone.
Hmm.
I'm going to let Rochelle talk.
Well, I mean, you're exactly right. Mines come into existence, they close just like Argyle. New sources are being found. Some of them are incredibly recent, 60s, modern. So I don't think there really is a known answer to that because there are so many different mines out there and different types of gemstones. So,
Hmm.
Carmen, if you have anything else to add, I'd welcome it. But yeah, that's kind of a hard number to say.
Hmm.
Yeah, I mean, I agree. It's a hard number, and there are some gemstones that are only found in one place in the world, and it's because of their very specific geology. Um, and one expects that eventually you won't find them again once they're mined out, but you never know. Because there's always people out there looking, and there's always people out there having fun out in the field. Um, so it's really hard to say.
Mm.
And I'll just give a fun anecdote because, new mines can be discovered in all kinds of ways. There's a story, I think it was Sri Lanka, which produces a lot of sapphires. And I think it was 2013. They had just laid down some fresh road gravel. And the story is that this truck driver was driving along, and as he was driving on the road, he thought, well, that's kind of shiny. And so all of a sudden he stopped, he looked down, and sure enough, it was a sapphire. And that actually created this huge rush of people who actually started digging up the gravel that they had just laid for the road. And eventually they traced back and found the source of that gravel, and it became a mine. So you just never know.
Wow.
Along the lines of that's incredible. Resource length times, I guess. Jeff asks, what is the future of the South African mines? Do they have 100 years left in them? So, any comment on that?
Um,
Wild estimations.
I honestly I don't know. The South Africa is an important place for diamonds, has been historically, but it's not the only place. Like we talked about Argyle and we talked about Australia. There were mines, still are, I think, in Canada. Um, Historically, there's also mines in Brazil, lots of different places. Botswana has become really important for diamond mines. Um, so I believe there are still functioning mines in South Africa, but it's not the ones that we remember from history. All of these mines have a limited resource.
Mhm. We've got a question here for Lindsay. Did the different types of metals or alloys lose value, strength, etc., as you remelt them multiple times? So you make some mistakes, uh, you remelt things. Does that affect how it behaves when you're shaping it?
I am not sure.
Hmm.
I've heard that it can become if you melt metal down over and over and over, I've heard that it can become kind of porous after a while. But I also know a lot of jewelers that will do that. They'll melt down pieces that didn't sell or things they didn't like, and then use that over and over. But there are ways to remove porosity once it's been cast. Like there are tools you can use to basically like beat it into submission, and it kind of closes the pores in the metal, so it won't like get brittle.
Okay,
And
interesting.
if you don't mind me adding, a lot of times people ask to reuse their gold jewelry
Mhm.
Hmm.
um, for new jewelry. And what people often don't understand is that you can do that. You can melt it and make new gold, but you almost always have to add new gold to that.
Hmm.
Yeah.
So it's never completely the old stuff.
Hmm.
And you can't, it's not a good idea to melt down work that has solder in it. So it has to be clean silver, clean gold, because solder has tin or some other things in it that makes it flow easily in heat. And so if you add that to the melt, that can also make it brittle later
Hmm.
on.
Hmm. That makes sense. Good to know.
Mhm.
I think lots of people are trying to do that with their inherited costume style jewelry, perhaps. This is a great question from Teresa. Is it expensive to start creating jewelry? What are some of the tools you would need to get started? Lindsay, I'm thinking about some of the wire wrap and some of that sort of intro stuff, maybe. Do you have any comments on that? Someone that's looking to get into making some jewelry on the side?
Yeah, if you want to do wire wrapping, that's probably the best place to start because all you need is just a few different pliers and wire or wire and stones, and you don't need a whole setup. But if you're like me and like most other jewelers, that sort of leads into hand fabrication. And before you know it, you've got a whole separate bedroom full of tools, and there's always more to buy. So is it expensive? Yes, but if you just start with wire wrapping, I think you'll be all right.
So it's a gateway.
Yeah, it is.
Couple of questions for Rochelle. Katie asks, what is required to gain access, permission to the gemstone area where you are? Is there any visiting
Mogok,
options?
Mogok specifically had to have a letter from a local, and this was paperwork that was done behind the scenes. So I'm not exactly sure of every step of the process, but it always involves a local contact. Um, right now, Burma's in the middle of a civil war that's been going on for years. So you really, I mean, I'm not sure that anybody's really visiting right now, or at least compared to what it used to be.
Mhm.
But other markets are easier to access. It would just be travel. And even in Burma, they'll have markets where they're in the major cities rather than in Mogok specifically. So
Mhm.
it depends.
Uh, Another question for Shell. We have all our gemstones from Colombia and Brazil, mostly mined by individuals or small businesses, or are there large-scale mining operations in these countries? Hmm.
There's larger scale mining operations too. Yeah. So I was mostly thinking about specifically sapphires, but even sapphires, you can have, larger scale mining too. I'm thinking of the Rock Creek deposit in Montana, which is actually in a really beautiful part of the state. And they have a huge, huge processing plant there where they have a jig. But Montana is really special too because they have very strict mining laws where you're mining and reclaiming, and you're only allowed to mine a specific, you know, area at once. And they do a really good job of reclaiming down to like putting the original fish population back in a lake. So it's really impressive to see.
Hmm. And I'm checking my phone here because I got a question come in. It's coming through the chat, and then Carla sent it over. So asking here, gold colors. Question about gold colors. Are they alloys?
Oh, probably. But like green gold,
Hmm.
I don't know what it would be alloyed with. Haven't looked into that. So
Um, I think
sorry.
green
Anybody
gold
else?
is alloyed with aluminum.
Oh, okay.
Aluminium.
What about rose gold and white gold?
Rose gold, I think, is copper, Carmen. Yeah.
Yeah.
And white gold. Oh, I don't know white gold.
White gold, it sort of depends on the age. It used to have nickel in it, silver and nickel. These days, sometimes you use palladium or platinum. It sort of depends. Actually, you can go for rose gold. This is one of the things I enjoy doing. You can go to a store at a mall and you can start asking for rose gold and start looking at the different brands. So every brand has its own recipe for making alloy of rose gold, and you can clearly see it if you look from brand to brand to brand. Now, my opinion, if you get to see a Levion piece, they have the most beautiful rose gold color. Other ones look like copper. So, but you can see how different brands use different recipes to make rose gold. It's too hard to see in yellow gold, and white gold is typically plated with rhodium, so you can't see it at all.
Thank you, Carmen. That's so interesting.
Cool. I'm going to jump in real quick. I know we have another like 4 or 5 questions that we'll definitely get to. I'm just going to jump in and do some closing things. So we're going to go real quick to Menti and just see. We're asking you all, if you didn't join earlier, take a quick scan of that QR code and answer some of the questions. But I wanted to go and review some of the things that have come in. So we have, our first question was about where people are joining us from. These little word clouds generate. So lots of people from Texas. Looks like Dan rallied some people in Indiana. Wow, we have people in El Salvador. That's awesome. We're going to make a cool map of this afterwards. So it's nice to have some international folks as well. And favorite gemstones. Wow, quite a smattering. I don't think this is smart enough to assign the right color to each of the
That'd be cool.
gemstones. That would have been good, but lots of emerald and tourmaline. Very cool. Watermelon tourmaline. That one's mine. So I'm glad somebody entered it for me. All right. And countries. So we got Brazil, South Africa. I think we've talked about many of these. Cool. Madagascar. Awesome. Cool. Any surprises out there, Rochelle, or anyone?
No.
Unusual?
No.
Awesome. Yeah, this was kind of a trick question because there are many, many steps. So I see it looks like many of them were captured.
I like diggy diggy hole.
There you go.
Patience. Nice.
Yeah.
Yeah.
Yeah. Time and money. Yeah. As we mentioned earlier. Alloys. This one was before, hopefully many of these people answered this before Lindsay's presentation, but it's like she covered all the major ones, and then there's some other smaller things in there that were alloyed into things. Cool. There's a pause. I want to see what have we got. Argentium. Yeah, that was a new one for me as well. Argyle story was super cool. And you know, this poll will be open longer, so if you want to go back and add some things in, you're welcome to do so. It's open, I think, through the weekend. So, and then this is just kind of a, you know, what do you guys want to see next? Bad geology movies. That one's in the process. The hardest thing for any of these, putting these together, is panelists. We had some connections to our all 3 of our awesome panelists for this event. But if anyone who votes for any of these has any ideas for panelist suggestions, feel free to drop them in the chat, please. And then we can follow up and reach out. So thank you. That concludes the Menti part. Let me just go back to our slides because I wanted to acknowledge our group here. We're going to go back to some more Q&A, but just wanted to say thank you, huge thank you to our panelists, Carmen, Rochelle, Lindsay. You all were phenomenal. We all learned so much from you, and future people who are watching this video will continue to learn from all of your expertise and passion and knowledge. And yeah. So thank you very much. Sponsoring organizations and our Geology volunteers, Carla Tucker, Andrea Reynolds, Kat Gould, Dan Kelleher, who are all on the call today. Myself, Rebecca Caldwell, and Chris Pila Cox are also on our team, and unfortunately are in the field today, who couldn't join us, but thanks to them. I wanted to see if AAPG or Midwest or Kat from Women's Network, if anyone has any announcements they'd like to make.
Uh,
Go ahead.
I can just say from our side, there's a YouTube link if you want to watch any recordings. As well, if you follow us on LinkedIn, AAPG Women's Network, you'll find out about any events that are happening like this. They're generally free. If you are inclined, please join us. It helps us support the organization. And yeah, I'll pass it to anyone from Carla. I don't know if there's anything from AWG from your side.
No, since it's the AWG Lonestar in Texas,
Oh yeah, sorry.
Chris is the one who knows about
Thought you
that.
might know through the grapevine, you know.
Sorry.
I know
Cool.
AAPG Lone Star has a field trip coming up in the fall, so if you're interested in that, I think it's a Wilcox field trip. So, and then Dan, anything from Midwest Geo?
Yes, actually, and thank you. There was several groups that logged in as large as watch parties, along as individuals. I want to mention Joanne from San Antonio who logged in today. She was representing and passed this along to the Southwest Gem and Mineral Society. Another shout out to the Minnesota Minerals Club. Had dozens of people logged in today from those organizations. Individuals who contacted me and said they would be on today, and I saw you here. Joshua, Maddie from Virginia Tech, Natalia, I saw you, and Diane from Champaign, Robert, Stephen, who I'm going to see in a few weeks at a short course, and Anna from AEG. She's one of the collaborators who's doing the annual meeting, and Chris. Each one of those people I saw logged in and said they were going to be on today. I tip my hat to you and glad you're here.
Awesome. Well, thank you all, and thanks all for attending. We're going to go back to some Q&A. You don't have to leave just yet. If our panelists are able to stick around for another 5-10 minutes or so, I know there was some more Q&A that we wanted to still get to. I just wanted to honor people's time commitments. If
There was one that got kind of lost too,
Yeah,
and that
sure,
was on
sure.
what treatments there are. And I'm glad because it actually gave me time to think through some of them, and I wrote like a little list. But
Perfect. Go for it.
so
Take
there
it
are
away.
many different types of treatments, and I'll just go over I'll just list the ones that come to the top of my mind. Before I go into that, though, one of the things to note is that it is actually illegal to not disclose treatments that you do to gemstones. And GIA was actually integrally involved with the Federal Trade Commission when they wrote these laws. So it's not only ethical, but it is required. That being said, so you can have heat treatment. There's both low temperature, which is very hard to detect because you basically reach those temperatures inside the earth. And then there's high temperature heat treatment. And this will often change the color of the gemstone. Either you want to lighten a blue and a sapphire or darken a blue. You can also coat gems, for example. Some of them are just coated with a coating to make them colored. And so you can see where the coating scratched at the facet junction, so on and so forth. There's doublets or triplets. So people might want to make something look like, say, a garnet or a sapphire. And it's really just, a blue, maybe even a bit of sapphire sandwiched between glass, or vice versa, or different assemblies of that. You can have lead glass filling, which basically makes the fractures less apparent, and so it increases the clarity of the gemstone. Things can be irradiated, like Jeff mentioned. They can be fracture filled in other ways. So I'm thinking of emeralds. Most emeralds are filled, and so there's actually a huge premium on unfilled emerald because they occur in metamorphic environments where there's lots of tectonic movements, and that'll create fractures. They can be diffused, so that would be beryllium or titanium diffusion, and you can see this in different viewing methods. usually immersion in methylene iodide. And so you can kind of see this like zone at the end from where the element was diffused in. There's internal laser drilling to remove inclusions. Sometimes you might have a dark inclusion in a diamond and you want that diamond to have higher clarity. You can actually drill that out in the inside with a laser. There's bleaching, there's dyeing, there's impregnating, and then there's proprietary processes like the Zachary process, which is a turquoise treatment. And nobody, it's proprietary, so nobody actually knows what they do, but it stabilizes the turquoise and makes it suitable for wearing. So there's probably others that I'm forgetting, but a lot of different things. And they're all fine because it allows more gemstones to be used. You just have to declare them.
Cool. Thank you.
Hmm.
Pat, do you want to?
Yeah, let's keep
Yeah.
let's keep going. You know what? I'm gonna ask you though, maybe stop sharing your screen and then we can get everybody extra big.
Good call. Thank you.
Yay. Sweet. All right. So I like this question because it mentions Canada. Also, it's a cool question. There's been a recent trend in southwestern jewelry using gaspite. Not sure if I'm saying that right. Gaspite. It's a very rare nickel iron carbonate. I can picture what that looks like in my head. It occurs in the weathering zone of nickel ore bodies mined in Western Australia and Quebec, Canada. For that reason, I suspect that most southwestern jewelry sold as gaspite is probably veracite. How would you spot fake gaspite stones? Um, any knowledge of this potentially fake stone floating around?
Probably have to take it to a lab because especially if it looks the same, or I don't know what its properties are, but a gemologist or maybe a lab if it's more complicated to verify.
Mhm.
I don't know if anybody else has a take on that, but that's mine.
Yeah.
Now, I don't know how to do it, but my guess is, so as a graduate gemologist, you use a lot of different tools. Some tools behave a certain way with carbonates that they don't behave with others. And I'm guessing that it might do that in those tools. So a refractometer, which is a simple tool, but takes a while to learn how to use it properly. It would definitely tell you if it was a carbonate rather than a not carbonate. But it's not something you can do just grabbing one and starting off without it. But I'm sure that, since I'm not an expert in jasper, but I'm sure that it has certain properties different than veracite, and you would just have to go through those properties. That's how we do it with other gemstones.
Makes sense. Okay, we've got an anonymous question about another kind of future-looking. What's the future of exploration geology look like in Australia for mining? What are the best products to go into? Wow, do you want to speculate on any places people should invest slash start working in Australia?
No.
No, this is being recorded.
I
No
don't
stock
give
tips.
investment advice.
No stock tips. Yeah. Okay. That is a research question for this person. Question from Jim. When you have a gem that reacts with light, diamonds, for example, is there a different setting used rather than for other gems, garnets, etc.? So I guess maybe do you use different light settings or to look at things other than diamonds?
I don't know. I guess it depends on how it's cut
Hmm.
because like most faceted stones, like with the culet, you want to set those with prongs. But I've seen jewelers use rough diamonds in jewelry, and it's different, but it's just as beautiful. And those can be set either like channel set or probably not a cab. Well, I guess you could cut it into a cab, but it really depends on how it's cut.
Mm.
Anybody else have thoughts?
Yeah, now.
Only thing sorry, you go
Go
first.
ahead, Rochelle, go ahead.
Oh, well, I was just going to say in the past, before they really perfected the diamond cut and made the modern round brilliant, they actually used to use gold foil to back the gems to help with the light return. But that's all I want to add.
Now, I use a lot of faceted gems, and I actually use bezel setting. So the setting itself isn't as big a deal as the cut of the stone. And by the cut of the stone, I mean the actual gem cutter knowing what they're doing, because it's not just putting in the facets, but putting them in at specific angles, which depends on what kind of stone you have. And so if you have a really well cut faceted stone, it doesn't matter if there's no light coming in from the back, because all the light should be returned. All the light that's coming in from the top should be returned back up. And that's based on how it's cut.
All right. So Black Hills Gold. Love that. They not sure of this question. This is that's natural, correct? Yes, as far as I know, there was a gold rush in the Black Hills in the late 1800s, so I assume that gold's pretty natural. But that's the question. Is it natural? I would say yes, based on my watching of Deadwood on HBO. Highly recommend. Any comments on that though? Maybe I'm missing.
If it's on TV, it's true, right?
That's what I've been told, right? That's what I've been told. I've always wanted to get down there actually, but I have not. Anyway. Okay, so question about star sapphire. Love it. What makes the star in star sapphire?
Oriented rutile needles. Yeah, so
Love it.
titanium oxide, and it orients along crystallographic planes in the sapphire, and then that causes the light to reflect in a star pattern, which is awesome. I love star sapphire.
Oh, wow.
I have way too many from Burma because everybody started selling me some, and then like the parcels kept getting better. So I was like, I already have a bunch. Oh, but those are really nice. So
Oh my gosh, it's so pretty. I'm looking at it right now. Cool. Jeffrey has a question about diamonds. This is really cool. I've heard of this, but any comments on microscopic GIA registry numbers that you can add to diamonds? Is that a thing that you can do now, or is that a rumor?
people do try to do that. Yeah, so they will use a diamond report number because GIA inscribes a unique number on the diamond, but we actually have a matching surface, so we can see whose inscriptions are fake, because it's just like everyone. We have a very specialized way of doing them.
Huh, very cool. And then Jeffrey also says ChatGPT has revealed that, if I'm pronouncing this right again, Veracite is slightly softer and has a lower specific gravity than Gaspite. So that was that question earlier about, there's very limited sources of this. People are selling it down the Southwest. How do we find the fakes? So that makes sense. And that actually was our last question that we have in the Q&A. Does anyone have any other questions? Again, if you want to throw your hand up, Sonia's had her hand up since the very beginning. So from when we started the webinar, so that might have been a different question. But Sonia, if you have a question, feel free to put it in the chat or I can unmute you. Otherwise, if anybody wants to speak as well, you just put your hand up and I'll unmute you. Other than that, oh, no, that's cool, Sonia. Glad you're still here.
I'm going to show up some watermelon tourmalines.
Awesome.
Ooh,
Oh,
very nice.
And then Carmen mentioned earlier about things that can only be found in some places. This is the most I've ever paid for anything because they're little bonitoites. They're very tiny, but they're very expensive. They're from San Benito County, and they're our state mineral here or state gemstone here in
Oh,
California.
cool.
Cool.
State gemstone. Very exciting. There's also a DC animated hero called Star Sapphire, apparently. Just when I Googled it, there's a DC comic around that too. So it's pretty cool.
Rochelle, if you facet a star sapphire, can you still see the star?
No, it happens with the cabochon surface.
Okay.
So one way to actually see if you might have a star sapphire is to put a drop of oil on top, and that will give you the same effect as cabbing the stone.
Oh, wow. Okay.
And
if you don't mind me just putting something out there real quick. For those who are in Houston, I actually teach beginning metalsmithing classes at the Houston Gem and Mineral Society. You can go to their website under education and classes, and when there are classes available, they'll be listed there. They come and go, but beginning metalsmithing, so you can get a sense of what it's like to be a metalsmith.
Awesome. Maybe we can do a short course with you at Image or some future conference.
That could be fun.
That could be really fun. Yeah.
Well, I had a question, kind of a follow up on an earlier one, maybe for Lindsay about getting into it. Like, are there, what's the word? Not like collectives, but like if somebody has a kiln, like can you borrow kiln time?
Oh, like a makerspace?
Yeah, yeah.
I
I guess it depends on where
believe,
you live, but yeah.
true, it depends on where you live. I live in Houston, so I know that there is a makerspace. I haven't been there, but they might have a kiln.
Sure. I was just
Um,
thinking like if you're making that step from like wire wrapping and you want to try something, but don't want to invest in purchasing your
yeah.
own equipment.
Yeah, check your town. There might be a makerspace or maybe another jeweler who'd be willing to let you use their equipment, either for a fee or some kind of trade. I know I took classes at the Glassell School here in Houston, and they have all the equipment you can need, and you can use it for the whole time that you're a student. So yeah, I would just check your town and see what's available.
And I'll
Yeah,
just
and
add on. Oh, sorry.
no, but you should also check your local gem and mineral societies,
Yeah.
because the Houston Gem and Mineral Society has a jewelry studio, and if you are a member, you can use the tools there. You can also learn how to cab. You can learn how to facet. You can do paleontology, fossil work, all sorts of things. So check out your local Gem and Mineral Society.
And I was going to add, there's a lot that you can actually do with just one of those creme brulee torches, especially working with silver. I'm
It's true.
a little bit of a hobbyist, and you really only need a couple more tools than wire wrapping. So it's kind of one step above on your way to casting and doing the nut stuff.
Gateway, again, gateway
Yeah.
drug of.
And there are some kilns that are really small that are like you can set on your desktop, and they might be, I don't know what their prices are, but like you don't have to buy this great big huge thing. It could just be like a little personal kiln too, if you know you're looking at kilns.
All right. Any other questions or comments or stories people want to share? Over 50 attendees still. Free to raise your hand and we can unmute you. Give you another minute or so. Oh, Gilbert. All right. Let's
I'm going to allow Gilbert to talk.
you gonna do it? Okay, perfect.
Hey,
Go ahead, Gilbert.
You got to unmute.
I guess I'll just go to unmute. Can you hear me?
Yeah. Yeah, you sound great.
Those desktop kilns, how much do those cost? Sure, they range. Lindsay?
Probably a couple of hundred, depending on where you get them. You could probably also find them used, like on Facebook Marketplace, or there are a number of Facebook groups that jewelers will sell their equipment they no longer want.
Oh, that's affordable.
Yeah.
Thank you.
Brenda.
So, Mike, can you hear me okay?
Yeah, you sound great.
Yeah, I'm sorry I joined late. I feel like I missed a lot. I guess, is this recorded at all so I can watch the first part? And then the second question I had was about Black Hills Gold Jewelry. I don't live too far away from where that is made. And it has different colors in it. It has like pink and green and the regular gold color. And I just wonder, how do they do that?
I don't know. I haven't seen Black Hills Gold. I don't know how it's different than, I guess, just regular gold. Carmen, thoughts?
It is my understanding, it is regular gold. It's just from that area, and the designs that they make are specific to that brand. The different colors are just different alloys. So a rose color would be yellow gold with copper. Like I said, I think the green is actually aluminum. It is just like all the other gold alloys. You just add different colors to it. Or you add different metals to it, you get different colors and different kind of intensities of color.
Okay. Okay. Thank you.
Yeah, and I can say, Brenda, I just threw the link in the chat, but as Carla said, that we post all our Geology Hub events in there's a YouTube channel with a specific section for these kinds of events. So fill your boots on there, and there's Geology of Pigments. That might be a popular one with this crew as well, as well as many beverages and foods that we've done in the past. Cheese and wine and whiskey and beer and surfing and rock climbing. Yeah, cool. Let's see here. Britt says that they had a tester kiln from Vivor that goes to 1200 degrees C and cost $300. Seems very reasonable. It's almost as cheap as an air fryer. There you go.
There you go.
Better temperatures.
Yeah.
If it goes lower, you could cook your chicken in there too.
I was going to say,
There you
it's
go.
flash cooked. All right. Well, last call for any unmutes or questions. Otherwise, I wanted to thank our panelists, thank our organizing team, thank our sponsoring organizations, and thank everyone for putting all this together. And thanks everyone for joining. And keep an eye out for this on the YouTube channel, and keep an eye out for other talks coming up in the rest of this year. Wanted to preview that we will be having a in-person version of Geology of Beer at the Image Conference in Houston, the joint SEG and AAPG conference in Houston on site. That's all. Thank you very much. Have a great Friday. Have a great weekend.
Thank you for
Bye.
having me.
Thanks for
Thank
having
you,
us.
everyone. Thank you so
Have a
much.
good weekend. Bye.
Bye.